Hey guys, this is Physiology Lab Week 1. I'm going to start with lecture. We didn't hit very much. We talked about the hypothalamus because we're working on regulation of appetite and weight control. This is all controlled by the hypothalamus. You have two different areas of it. The lateral portion is known as the feeding center. It lets you know when you want to eat. Yeah. The medial part is known as the satiety center. It tells you when to stop eating. You've had enough. The signals that track that to stimulate feeding, you have orexinogenic with an O, that's when you want to eat, and anorexigenic when you don't want to eat. So think anorexic, you don't eat. That's the fiber that makes you not eat. Hormones and neurotransmitters all have an effect on when you want to eat. And that's all there is for lecture. I'm going to move into lab. We talked about the different cycles of the heart in order to get a signal. We'll start with contractile tissue. This is when you want to make the muscle contract. You got 4 different phases. You got phase 4 when you're just at the resting membrane potential. Phase 0, sodium channels open up and create that action potential. At the top, you reach the peak, sodium channels close, calcium starts coming in, diffusing from the ECF, and potassium slowly starts coming out to counterbalance. It'll continue to go down. Calcium is flowing in at phase 2, and as well as potassium still coming out slowly. Finally, it starts to repolarize quickly, which is stage 3. That's potassium coming out fast. Again, this is for contractile tissue. When we want to talk about rhythmic, this is what's going to happen in the SA node spontaneously. We have leaky sodium and calcium channels. So it starts here, sodium slowly coming in to create that curve. Calcium will then take over at phase 4 and slowly start coming in until it reaches that resting membrane potential, and it'll start spiking up, and calcium will open, the channels will open, and it'll come in quickly. That's phase 0. Potassium will then start going out, and it's going to repolarize quickly, and you're back to the curve that's starting to go up. In terms of the signal, it's going to travel starting from the SA node. It'll travel to the AV node. It'll then go to the AV bundle, or the bundle of His. It'll travel down the bundle branches and go out to the Purkinje fibers, and that's what will eventually reach the muscles. In terms, the SA node, if by itself left unregulated, it would be moving the heart at a heart rate of about 100 beats per minute. If you lost control of the SA node and went to the AV node, it'd be going at about 40 to 60 beats per minute, if there was no other information coming in from the autonomic nervous system. If you have a heart rate that's greater than 100 beats per minute, you know that sympathetic is involved. It's involved by talking to the SA node and the AV node, all of which are going to make it the rate increase in the conduction faster once it gets to the AV node. It also has an effect on the ventricles by making them squeeze harder, thus increasing stroke volume. If you have a heart rate less than 100 beats per minute, parasympathetic innervation has control. It speaks to the SA node and the AV node by slowing them down. Parasympathetic works through acetylcholine. Sympathetic will work through epinephrine and norepinephrine. Moving on, we got to the PQRST waves. This is what the ECG is going to be picking up in terms of the heart rate. The first thing here is the P wave. This is all looking at electrical activity, so this is not showing any kind of muscular contraction. Starting with the P wave, this is atrial depolarization. And then somewhere between the P and the R wave is when you'll have atrial contraction. QRS, this is the ventricle depolarization. Also hidden in here is atrial repolarization. Somewhere between the S and the T wave is when the ventricle will actually contract. Because remember, it needs time to bring in that calcium before it can actually contract. Finally, the T wave is ventricle repolarization. And that's it.